Welcome to the 18th edition of the Panama Interview Series, where we discuss topics regarding foreign direct investment in Latin America and the Caribbean. We are streaming live from the capital city of the Republic of Panama. The Panama Interview Series is produced by Bico Legal and Compliance Consulting, LLC, a Miami domiciled limited liability corporation with offices in downtown Miami and Panama City, Panama. We provide international, commercial, and transactional legal and regulatory compliance advice and related services to manufacturers and brand owners that seek to boost profit and hedge domestic risk through international distribution in the USA and in Latin America and the Caribbean. My name is Anthony Robinson, and I am the managing member of Bico Legal and Compliance Consulting. In the next several editions of the Panama Interview Series, we will discuss the future of probiotics in Latin America and the Caribbean, and the potential of probiotics to contribute to the post-COVID economic recovery of the region. Digestive health and probiotics is one of the most dynamic sectors in the global health and wellness market, and Latin America is poised to be one of the fastest growing regions in the world for the consumption of probiotic and digestive health products. Given that the economies of Latin America and the Caribbean are forecasted to decelerate in 2023, with an estimated growth rate of only 1.3%, according to the Economic Commission of Latin America and the Caribbean, it is imperative that we identify and support economic sectors such as digestive health and probiotics that have demonstrated growth potential. Today, we focus on the emerging development modality of precision probiotics, which promises to significantly improve the efficacy of probiotics and enable manufacturers and brand owners of probiotic supplements to identify the best probiotic strains for the specific health targets of individual consumers. The promise of precision probiotics is the application of probiotics to personalized nutrition and preventative medicine. Exciting stuff. To that end, we are honored to have as our guest Jordi Riera, Chief Business Development Manager for Kaneka Probiotics. Kaneka Probiotics is a division of Kaneka Americas Holding, Inc., and is a leader in the development of scientifically based ingredients for the global nutrition industry. Kaneka Probiotics is committed to promoting business development to provide solutions that support healthy and energetic lives. As Chief Business Development Manager at Kaneka Probiotics, Jordi Riera is responsible for strategic account management, innovation and product development, and the technical support of sales, marketing, and educational initiatives. Jordi has been responsible for the launch of over 250 probiotic products in more than 90 markets worldwide. We have several topics to cover in 60 minutes. Accordingly, please put your questions in the chat and I will submit them to our guest afterwards. Let's jump in. Jordi, how are you doing? Thank you for taking the time to speak with us today.
Thank you, Anthony. I'm very honored to be part of this conversation today.
You were just in Barcelona at the International Probiotics Association World Congress and Probiota. How did it go? How did you enjoy it? Tell us a little bit about the Congress.
Good. Actually, probiotics is very interesting all the time because it has a good conjunction between what is the industry trends. So having a pulse on the market, while not leaving aside the state of the art in terms of science. So we could have a good sight on what's going to be next in probiotic landscape. We see that science is becoming more and more sophisticated. So the classic approach to have, let's say, a purely manufacturing-oriented activity in the sector is a matter of the past, and more companies and consumers and brands are trusting probiotics that are sophisticated, are in the new paradigm of precision probiotics. So that was interesting.
What were the 2 or 3 most exciting developments in probiotics that were discussed at the Congress?
Yeah, personally speaking, I found very interesting 4 items that I recall right now. One was the combination of probiotics with other ingredients. For instance, we know that there is a big interest into seeing how combinations with things like HMOs can help into developing better symbiotics in that case. Also, postbiotics were around for a while, and the new definition that was issued in 2021 by the ISAP helps into developing this field that allows to apply the products into a broader range of applications. Also, in terms of probiotics themselves, in my opinion, actually, Gabriel is still a hot topic that is just appearing every congress that you attend, and I believe that it's a long way to develop interesting products. And menopause is also showing a little bit that it will be a next area where probiotics can hit hard and offer a good solution for women all over the world. So, in my opinion, that would be the 4 items that was more interesting this edition of Probiota.
Well, the future is very promising for probiotics. Kaneka has established itself as one of the leading precision probiotic companies with a commitment to identify the best strains for specific health strategies. One of Kaneka's competitive advantages is Kaneka's process for discovering its precision probiotics. In a minute, I'm going to ask you to walk us through Kaneka's discovery process for precision probiotics. But before we do that, let's provide some context for the discussion. Namely, let's establish the difference between precision and non-precise probiotics. So, the first question is what is a probiotic? Let's just start at the very basic.
Well, actually, the definition of a probiotic took place many decades after the probiotics started. So probiotic concepts were the concept of a probiotic was discovered first by a Russian scientist called Menshikov more than a century ago, but the definition was issued just last decade. But yeah, the definition is very clear. So we know that probiotics should be living microorganisms that distinguish them from prebiotics or postbiotics. So they should be living, and that's very important on a quality perspective as well, because living means that they should be alive through the shelf life of any product, and that on a quality perspective is an important point. But the second important point, besides the fact that they should be alive, is that they should confer a benefit to the host, to the health of the host. So it should give a benefit to the health of whoever is taking the product.
Another benefit that resonates is that the health benefit of a probiotic must be demonstrated beyond inherent general nutrition. So not every strain that exhibits a positive health benefit is necessarily going to qualify to be as a probiotic. And the demonstration of that benefit must be scientifically substantiated. So, the question is, why is that distinction important? Why isn't it enough that a strain, exhibits or a positive benefit is observed in correlation with the administration of a strain?
Well, I mean, the effect should be clinically proven for different perspectives. First is that when you administer a product to somebody, you need to understand that this benefit is replicable, so that this is not a benefit that just will benefit a spot application of the product, but it will benefit a general population or that have the intended use for that product. And secondly, we should distinguish what probiotics are versus other health associated foods, like could be yogurt or kefir. We know that yogurt, for instance, is good for gastrointestinal health, but automatically doesn't mean that a yogurt is a probiotic. A yogurt can make different effects, different beneficial effects, but that are not replicable, and one yogurt is different from another. So, and that's where the strain identity becomes so important. Actually, I like always making a comparison of how important a strain is versus a species or a genus. If you take the example of a dog that scientifically speaking is called the Canis familiaris, the species of the dog is the Canis familiaris. That would be the bacterial species. But when it comes to the bacterial strain, the dogs also have different strains. They have different breeds. And when you want, for instance, a dog to look after a herd of sheep, you would take a Great Dane, powerful dog to keep the wolves away. But when you want to have a dog at home, you will take a Chihuahua, which is small and goes well in a small apartment. But you would never put a Chihuahua looking after the herd. So for bacteria, it's and probiotics is exactly the same. You would not take a strain that is beneficial for one thing into a very different thing, no matter if they are the same species, because the species doesn't tell us anything about what the strain will do.
Okay. What are the possible mechanisms of distribution among probiotics? Now that we understand basically what a probiotic is, what are the ways that probiotics work in the intestine or affect the gut microbiota?
Well, that's a very open question, because in the beginning of probiotics, we all, or still nowadays, many consumers may think about that, but we were expecting the probiotics to modify microbiota, just to modulate the composition of microbiota in the gut. Now we know that microbiota is no longer just a matter of the gut. We know that there is bacteria all over the body playing a role in places like mucosas, like mouth, like vagina, even on the skin. Now it's a hot topic, in the lungs, and even now we know that there is microbes playing roles in the conjunctiva, so in the eye surface. So we know that the probiotics are no longer meant to be modifying just the microbiota in the gut level, but moreover, we know that the probiotics are not just inhabitants of this microbiota. Some microorganisms can help the body do their physiological processes. They can activate neurological cascades that can activate immunological response. So probiotics become a very complex tool that can be leveraged to tackle different health issues.
So we have some strains that are complex and may demonstrate or manifest many different effects. But on the other hand, we have rare strains that are very specific in their effects. But would you expect to have any one strain that is on all facets of this pyramid?
No, well, I mean, the nature is very wide and very diverse, but the truth is that the more complex is the effect that you want to achieve with a probiotic, the more difficult would be to find the right strain. So we know this is extracted from actually from the paper that defines the probiotic definition. And Isaac was pointing out that while there are some benefits or some features that a strain that any strain may have, like for instance capacity to colonize or compete with pathogens in the target of the probiotic, there are some effects that are very strain specific, that are very rare, that are very hard to find in nature. And I'm thinking, and precisely these strain specific effects that are on the top of the pyramid are much more related to the concept of precision probiotic. When you have a strain that is meant to activate a gut-brain axis response, or that can activate a particular immunological effect, or can activate a particular part of the endocrine system that can help the obesity, that can help fatty liver, that can help cholesterol reduction, or even produce particular bioactives that we could call postbiotics as well. Not any strain can do that. While any strain of probiotic is meant to colonize, not any strain can do these very complex effects. And that's where it comes, the importance of counting on a broad range of candidates of potentially probiotic bacteria, so we can identify among a broad range of candidates these few rare strain-specific effects to deliver better products.
Okay. How are probiotics administered? What are the means of administration of probiotics?
So the probiotics can be administered in many ways. The key aspect is that, so one way to answer this question, one angle would be on the matrix where you administer the probiotics, and then it comes the probiotics can be in capsules, powders, liquids, foods. Any format is possible, as long as you keep the first part of the definition in mind, that the probiotic should be alive along the shelf life of the product. And that sometimes is a limiting factor, especially, for instance, if you want to apply a probiotic into a food or into a beverage where the stability is a tricky point. So the administration, the way you administer the probiotic is not limiting for their application, as long as you keep that part of the quality in mind. The other angle to answer this question is the category, the regulatory category of the products. And here, I think that worldwide, there's still very few examples of countries that have done the exercise into developing the right framework to register probiotics, because we have examples of same product that in Europe or in the US can be a dietary supplement. In the US, you can do some claims over the health benefit. In Europe, you cannot do any kind of claim at all. But the same product in some parts of Central America can be a biological drug or a natural health product. In South Korea, it can be a functional food. In China, it can be a general food or a functional food. In Australia, it can be a complementary medicine. So you have different examples of categories that the exact same product can be, let's say, marketed in different forms. Actually, a good point is that more and more authorities are taking awareness of that. And in Latin America, we have a prime example of a country that did a great job, in my opinion, into making the effort to define the right framework to register products. That it's Brazil in that case. Brazil and Visa did a very conscious work, working with the industry, working with the academia into defining a framework to develop products. And actually, that has been proof that by defining the right framework, you can give confidence and safety to the companies and researchers, and they have dynamized a lot the market. Other example is Canada. We have other examples all over the world, but I think that this is still, generally the market goes 2 steps ahead of the government and the authorities, and we are seeing how this is evolving every day.
Can you speak to some of the recent developments on probiotic drugs?
Yeah, actually, probiotic drugs were like a target that everybody wanted to achieve, but nobody could see before recent times, as I will explain. So there was a broad interest in the industry trying to achieve the approval of a probiotic drug that was never achieved in one of the reference frameworks since more than 20 years ago. But in recent times, a couple of months ago, we got 3 approvals in a row, 2 for a fecal microbiome transplantation and 1 for a vaginal suppository. One example is a fecal microbiome transplantation approved by the FDA to the company Ferring. There was another approval of a fecal microbiome transplantation, a different company in Australia, TGA. And more recently, there's been an approval for the first time in EMA framework of a drug, vaginal suppository, by one of the European agencies, in that case, the Italian agency. So these 3 examples that are very recent, in my opinion, have broken a little bit the eyes of this potential category that would allow many more developments that will go beyond the standard health benefit over healthy population. So now we can see that many products, many probiotics that can deliver a benefit to conditions that are severe, like kidney conditions, like conditions of the heart, like inflammatory conditions of the gut. So many other conditions where the probiotic could play a role, but we had the limitation of the regulatory framework. With these approvals, we now open a nice window for new innovation to achieve the patients in that case. And I think it's very important.
Yeah, really promising about what's possible in the future. So we've established what a probiotic is. We've established the administration means. We've established, the basic framework. Now, could you tell me what is the difference between a precision probiotic and a non-precise probiotic?
Yeah, sure. I mean, precision probiotic concept was introduced by the academia some years ago. But in a way, a good angle to see that is that the precision probiotic is a product or the probiotic strain that is not just having a broad effect, not just having a specific mechanism of action other than just colonizing, and that can confer a broad range of benefits that are not always clearly tested. The precision probiotic is a strain that we define very well the mechanisms of action through which the strain will act, and that we prove in clinical trials that these benefits are achieved. at the level of the host. So in a way, it's a different angle to develop products in our industry.
Okay. Well, based on that understanding and the framework that we've developed there about the difference between probiotics and precision probiotics, let's discuss Kaneka's probiotic discovery process and what gives Kaneka a competitive advantage. We know that historically the discovery of probiotics has relied on the identification of bacteria enriched in healthy individuals or individuals without specific health pathologies, also known as a top-down strategy, and target identification at the cellular level, or what is termed as a bottom-up strategy. Scientific literature instructs that the top-down approach covers observational evidence, causality testing in animal models and humans, and in some cases, mechanistic or host response characterization. In other words, the top-down approach identifies a correlation between a microorganism enriched in a healthy individual and a health benefit upon administration to humans, right? So we have an illustration here that tries to show us the difference between the two strategies, a top-down and a bottom-up strategy in the development and identification of probiotic strains. The interesting aspect of this illustration is that all roads lead to the precision probiotic in this particular slide. So, Jordi, could you speak to what are the strengths and the weaknesses of these two, I'm not going to say competing strategies because they look like they collaborate, but between a top-down and a bottom-up strategy, what are the strengths and weaknesses of those two strategies?
Yeah, in a way, the top-down approach was the classic way where the first probiotics were introduced. Actually, you identify a bacteria living in healthy individuals, and importantly, this bacteria is generally identified because it has the capacity to colonize. Because with this top-down approach, what you expect a probiotic to do is to colonize microbiota and modify microbiota in a specific way. Then the qualification of the mechanism of action in this top-down approach is a post-hoc description of how the probiotic achieved this colonization in healthy individuals. And whenever you identify that the mechanism is A, B, or C, then you can qualify it as a precision probiotic because you have a precise way it can act potentially. But in my personal opinion, that's quite limiting for bacteria if you want the bacteria to do more things than just modifying microbiota. And I'll come back to it with some examples. On the contrary, bottom-up approach, the mechanism of action discovery, it's not the post-hoc aspect of the development. It's one thing that you need during the development process, during the qualification, the discovery of the bacteria, because through the mechanisms of action, you discover the right bacteria to achieve a particular health benefit. The different angle of this is that you can identify many more benefits, so you can identify more things beyond the just colonization and modification of microbiota. For instance, you can see these aspects of the top of the pyramid that we saw a few slides ago, where the strain can cross-talk with the body, can activate different mechanisms through which bacteria in conjunction with the organism can perform much better in terms of many more and more complex health issues. Interestingly, also through this mechanism, you can also have a different angle. That is that you can combine different mechanisms, different strains, achieving different mechanisms that we describe into more sophisticated combinations, more sophisticated blends that can allow us to personalize, to target much better, to stratify much better different and complex benefits to achieve in the future. And through the advance of the basic science and R&D work describing how complex conditions are driven by mechanisms that the microbiota can play a role, we always can use strains that we know very well the mechanisms that they perform immediately into targeting these diseases. We had several examples on that. For instance, we discovered for the first time just a couple of years ago during the research we did in probiotics in COVID pandemic that the microbiota strains without modifying microbiota could activate the interferon type 1. And interferon type 1 is a route that the science knew for a long time that can help into fighting viral conditions, viral problems. And through the administration of probiotics and not modifying the microbiota at all, but the administration of right strains, we can help the body improve this immune response or activate this particular mechanism. We have other examples in other parts of the organism: gut-brain axis, gut-liver axis, gut-skin axis, gut-lung axis. All these gut something axis are something that the precision probiotics can be a good leverage to tackle complex conditions.
The literature speaks to the dichotomy between homogeneous strains and heterogeneous strains, and the fact that the common understanding is that a probiotic has a homogeneous effect across hosts, but the empirical research bears out that there's a lot of heterogeneity. Could you help me and help the followers understand the difference between those concepts? And when the literature speaks to heterogeneity, my understanding is that it's speaking to the fact that the effect of a probiotic is a combination of what the probiotic strain is wired to do, for lack of a better term, and the resident microbiome, right? So the environment within which it operates has something to do with whether it's going to be able to get to an achieved end. And that's something that we, scientists have not been able to predict with a lot of consistency because that environment's individual. And, so could you speak to that difference between heterogeneity and homogeneity?
Yeah, sure. Give you some example. For instance, now it's understood that every individual has a fingerprint, a microbiome fingerprint, sorry. So every microbiome is different, and everybody of us have a different microbiome that is not necessarily better or worse than anybody else's. So that's an important aspect, because when it comes to how probiotics may act, if we have the sole application of probiotic as a modification of microbiome, we may not achieve the right benefit. So if we have potentially healthy, even though it can be different, a potentially healthy microbiome, we don't need to modify it at all. And that doesn't make the probiotic useless, because the probiotic don't necessarily need to modify the microbiome to achieve the benefit. And that's important when it comes to the heterogeneity. We have these different microbiomes, as different as many as people exist in the world, probably. If we limit the way probiotics can act into the rough modification of these individual microbiomes into a standard microbiome, we are limiting ourselves the way that the probiotics can be useful. Well, if you have a precision probiotic mechanism through which you can activate particular physiologic processes in the body that don't depend on the microbiome composition, you have a much more powerful product, because it can be applicable regardless the heterogeneity in the microbiome. That's also having a different angle that, for instance, for some time in the market, there have been a proliferation of products just claiming to have a very high count of CFU in the pack, because the intuition that we're trying to educate to the consumers was that the more amount of CFU, the more powerful into modifying the microbiome, or to modifying the microbiota, conditioning the composition of microbiota. And that's basically something that is not true. So having a big amount of bacteria, most probably of same kinds of bacteria that are commercial, that are standard, that are, like, say, from an industrial origin, doesn't make it powerful at all, because you are modifying things that are unique on you, that is your own microbiome, that doesn't necessarily need to be similar to something that is commercially available on a shelf. Also, because there is a different angle on that, that is that there are many species and strains of bacteria that are very positive in our gut that cannot be cultured, that are not possibly administered in a commercial product. And we cannot limit the harvesting of the proper microbiome to the fact that we have microorganisms that we can culture in a standard fermenter. I think that this is a couple of angles that may respond to your question, but yeah, I think it's important to keep it in mind.
Okay, and so this illustration indicates that all roads possibly could lead to precision probiotics, meaning whether you have a top-down strategy or a bottom-up strategy, you can get to a probiotic that is designed for a particular health outcome. But the question is, what is the most efficacious strategy to get there, right? Because if we understand and we appreciate that precision probiotics is where the value is, right, in the future. What's the most efficacious way of getting there? A bottom up or a top down strategy?
Well, I mean, in the top down, you first identify the bacteria and then identify the mechanism. So the bacteria is identified not because of the mechanism; it's identified because of where it lives. That is a healthy individual. And the mechanism is a post-hoc qualification of this bacteria. In the bottom-up, all the process of identifying the bacteria is related to the mechanism of action that you expect the bacteria to develop. So in a way, it allows you to develop a broader range of probiotics, a broader range of products, because you are not limited by the fact of the identification before you know the mechanism. So in the end, the power of the bacteria will depend on the bacteria, but in the top-down approach, you just put all your eggs in one basket. That is the bacteria that you identify before the description of the bacteria. While in the bottom-up, you do a much more targeted research because you know what the bacteria should do before understanding what is the bacteria that will go eventually into the product. So both can be qualified as precision probiotics, but the bottom-up approach would allow you to be much more precise in the way you identify the right strain.
Right. Well, I think now we have enough framework so we can appreciate what is unique about Kaneka and its approach. So if you could please just walk us through Kaneka's probiotic development process and tell us what gives you a competitive advantage.
Yeah, sure. So we in Kaneka Probiotics we have two different ways to compete in terms of developing better products. One way is trying to count on the right pool of candidates. Right pool of candidates means that we want to have a good mine of potentially probiotic strains that we can use when we start any research. So if you want to find this rare, and I go back to the pyramid, these rare strains that potentially can confer a very complex benefit to the host, finding a rare among nature force you to be able to screen within a broad range of candidates. And one way we do that is the strain bank that we own, and we will explain it later. The other way to compete is the way we select the right candidate. And that comes to the way we make the screening of our products, the way we describe in experiments that allow us to identify the right bacteria, the way we describe the mechanisms of action that we want the strains to develop in order to achieve the benefit that we intend to achieve.
So we start off with the concept that we have microbial old friends that help us stay healthy because of their diversity in our gut. And over time, as we become more sophisticated and modern, we've lost them. Can you speak to that and explain it better than I just did?
No, microbial old friends was formerly known as the hygienic hypothesis. It was introduced in 2003. from the academia again. What this theory explains is that modern lifestyle, in particular things related to diet, the stress, the hygienic conditions, fermented foods, commercial cultures, all these factors have influenced our microbiota in a way that the microbiota of the modern human being is much poorer, less diverse, less functional than it was centuries ago before the Industrial Revolution. So that's why it's called microbial old friends, because in a way, these microbes that we lost were initially something that comfort us several benefits. For instance, we see that in parts of the world where people is still living in pre-modern conditions, the microbes living in their organisms allow them to be better in things like, for instance, allergies, autoimmune diseases, inflammatory conditions. Another intuition is that there is indigenous people living next to a river, and they drink on a daily basis water from that river without any issue at all. That's the way of living. While for a Westerner or somebody living in an urban area in modern conditions, in a modern lifestyle, if they go, same human being going into this rainforest and drinks from the same river of this other human being living there, this water would be potentially killing this this other human being. And all that is about obviously the immune system, but more in particular about the difference in the microbiome. That microbiome of this, let's say, individual living in this premodern lifestyle is in a way more prepared to help this guy walk through the conditions of this premodern lifestyle. So the intuition was that if this microbiome that we have in our modern society has been diminishing in diversity and functionality, the way to develop better products would be to try to find these old friends that we lost in the past years or centuries and bring them back into the modern times. Since we don't have a time machine, the way to do that was going in places of the world where this time machine would be a reality, because the people living there would be living in the same conditions as we would be living over a century ago before the Industrial Revolution. So that's why we did expeditions in remote areas of the world, from rainforests in Latin America or Africa or Asia, or even in rural areas in the mountains, or in and also beyond the gastrointestinal samples. We took samples from vagina, samples from oral cavity, samples from breast milk, trying to have a pool of potential microbial old friends that would allow us to develop any product whenever we decide to tackle a new development. So all these samples allow us to build up a strain bank, and this strain bank is, let's say, a long queue of candidates of potentially probiotic. I'm saying potentially because till the point we explain that they, or we demonstrate that they achieve a benefit, it cannot be called a probiotic, but potentially probiotics that are there waiting for us to research and to identify through a screening whenever we want to develop a product for a particular benefit.
And the clinical validation stage, what's happening in stage 4?
Yeah, sure. So as I was saying, all these candidates are potentially probiotics till the point we demonstrate a benefit to the health of the host. So demonstrating a benefit to the health of the host means having the clinical validation. So in any process of screening, what we do is walk through the research, the search for the bacteria that would follow a particular mechanism of action, to identify over a pool of thousands of candidates which would be the champion at this particular precise mechanism of action. And out of this identification of the right candidate, next step is to verify that this hypothesis of understanding that this one candidate or a combination of candidates would be the champion at this condition, we need to verify that in a clinical setup. And after the clinical validation, we can consider that the product is a probiotic and that is a reality that we can offer to the market.
And would this be correctly classified as a top-down approach, what you just described?
No, actually, it's the other way around. It's a bottom-up approach totally, because all this scrutiny, all this search for the right candidate, coming from thousands of candidates to very few or to single one, is done in a let's say in a criteria of a mechanism of action. So the thing we do is, before we develop a product, we try to think which mechanisms related to a bacteria could be helpful for a condition. Out of the mechanisms, we define a battery of experiments that will allow us to identify which strains in this pool of candidates would be developing the mechanism of action that we intend to have. So the mechanism is before we identify the bacteria, and it's bottom up because we start for a big pool of candidates and we end up with one finalist or champion in this development, or this is a research.
Okay. So what role does in silico or in vitro or in vivo technologies, what role do those technologies play in the development process?
Depending on the mechanism, we can use a combination of them. So for instance, if we want to identify an expression of a certain gene, for instance, developing or metabolizing a particular molecule or producing a particular enzyme, we can do in silico, because we can look for the gene that would encode for this expression. But for instance, when it comes to, let's say, mechanisms that are related to the interaction with other cells, like for instance, inflammatory conditions or inflammatory mechanisms, we may need a preclinical or an in vivo screening with a cell line or with an animal trial. Some other parts may be in vitro, for instance, antibiotic resistance or competition with other pathogens. So we should mix the different methods to find the appropriate mechanism or pool of mechanisms and to find the right product in the end.
Mm-hmm. And so we have these different technologies that at the end being validated clinically. Is that correct?
Yeah, exactly. So all these methodologies are to identify the right strain. And when we find the right strain, then we move into clinical. And with clinical, we verify that all the assumptions that we follow during the screening with the different methodologies are a reality in terms of the clinical substantiation of the benefit to the host.
Okay. And is there any risk of having, conflicting results, in the sense that we might have, this is a bottom-up approach, but we might have an empirical process where we have different results that might be conflicting about a particular host or a particular application of strain to microbiota?
I mean, it's science. In science is not exact. Probably just math is exact. So in science, you always have a risk of conflict and a risk of having results that are not replicated. That's why we don't just stay in one single clinical trial when we develop a product. When we develop a product, we immediately replicate the clinical trial and we continue the development of the product, understanding how other benefits can be achieved with the mechanism that we identified in other conditions. So it's a research in progress all the time. And when a conflict arises, we need to go back and review the process and review whether the mechanism was the right one, whether the mechanism was substantiated enough on a basic science, and continue this continuous review.
Okay, well, this is a good segue for you to speak about some of the research that Kaneka has done in this regard.
Yeah, actually, to give you an example, we have a product that is good or was originally developed for inflammatory conditions of the gut, like IBS, like diarrhea, bloating, pain, etc. That we discovered that through a particular effect at the level of gut permeability, let's say strengthening the tight junctions of the gut epithelium, could be helpful for a very different condition, that is the food intolerances. And we did 2 different studies, one in lactose and one in fructose, showing how, in that case, for lab-intensive GI I31 in different parts of Latin America could be helpful both for these inflammatory conditions, but at the same time can be helpful for people having symptoms of food intolerance. It is the same mechanism, but the clinical validation allows us to offer the same mechanism in different conditions. And that's a prime example, in my opinion, of how valuable it is to do the continuous review and continuous research of the evidence, especially because the basic science, that is where we look at anytime we want to develop a product, but the basic science is evolving. So one mechanism that we discover, maybe we don't understand right now, that it can be helpful for a condition that in few years in the future may be discovered at some part of the world that mechanism could be helpful for a different condition. And that may allow us to have this strain that we knew that was doing the mechanism of action applied into this new condition, thanks to the advance of the basic science. So I'm always encouraging that, besides the fact that we are a company that we need to make money with our research, it's very important for us to leverage the basic research. So it's very important for institutions to support the basic research, because basic research allow companies then to apply the know-how in developing products into new benefits for a broader population, a broader audience of consumers and patients all over the world.
So we or Kaneka has done some research on IBS and the potential of precision probiotics to address lactose intolerance and fructose intolerance. Can you speak to some of those developments?
Yeah, sure. I was explaining. So the important part is that we don't enrich the probiotic in the benefit. So what defines the probiotic product is not the benefit that we achieve with the clinical validation, but one step before. What defines the probiotic is the mechanism of action. When you have a very powerful, well-defined mechanism of action, then you can think about how this mechanism of action can help in different conditions, in different health benefits. So prime example is this product that, out of a mechanism that was originally developed for IBS, and IBS is a condition that have inflammatory problems and have a leaky gut situation, has a problem of dysbiosis, and understanding a mechanism of action that leverages the production of particular metabolites, postbiotics, that can help in the tight junctions, that can modulate the inflammatory pathways of the gut and the body. But the same mechanism was helpful for another condition that is different in principle, and I'm saying in principle because in reality it has similarities, that is the food intolerance. What happens when you have a food intolerance to fructose, to lactose? In a way, it's like a temporary induction of a kind of IBS, because the food intolerance, what activates is an immune reaction that causes a leaky gut, or that is derived from a leaky gut situation, but causes an inflammation that in the end results in a very similar symptom as the IBS. So by understanding that there is a common root in the mechanisms or in the pathophysiology of the two conditions, we understood that the same product could be applicable to these two conditions. But the mechanism was essentially the same. The mechanism through which we tackle the two conditions is the same, but the conditions are different, and the population that benefits from the product is different.
Okay. And, at the root of the efficacy of probiotics and precision probiotics seems to be a lack of information. If we had more information about individuals and their microbiota, we would be able to design probiotics or identify probiotics more, more easily and with more efficacy. So, the Journal of Genetic Counseling estimates that by 2030, over 100 million Americans will have their genome sequenced, and that a significant proportion of the general population will have their microbiome sequenced. With this, if that comes to fruition and scientists have the facility of that information, what effect will that have on the efficacy of probiotics and precision nutrition and preventative medicine, including precision probiotics?
So yeah, well, that was a little bit what I was trying to stress when I was mentioning the basic science. So when science allows us to understand different pathways through which we can, from the perspective of microbiota, influence in physiologic mechanisms of the body, it opens a door for more applications of probiotic products to a broader range of conditions. So back in the times, for instance, we introduced for the first time in the world a probiotic that could lower cholesterol, and it was clear the mechanism through which the product was lowering cholesterol, and it was clear the benefit of lowering the cholesterol. But I mean, sometimes the science understood that, but the market was not yet understanding that the probiotic could lower cholesterol. So it's very important that we do a research to advance in understanding how, from the microbiota, you could influence different aspects of the human physiology. But at the same time, it is very important to continue the education of the audience, education on the public, on the consumer perspective, but also education of the brands, of education of products that are taking the responsibility to market products, because it's very important to educate how powerful it is, the microbiome, into helping different aspects of the human health. So yeah, I think it's a work in progress that we need to insist on, that we need to take a very take big care of, and we need to take care of this education, because in a way this is also a path through which us as industry can allow innovation to reach market before we commoditize the market. So it's very important that we act responsibly in having the right substantiation, to making the right claims, to making the right clinical work to substantiate our products, and not to overpromise on the products that we put on the shelf. And that's, I think, a big responsibility we need to take as an industry.
The last topic we're going to cover today is the application of precision probiotics to Latin America and the Caribbean. This slide is speaks to the potential positioning of probiotics given the health concerns in the region. We have this this cross axes here, where everything in the top right is concerns that are also affecting people in their real lives, and these seem to be ripe opportunities for Kaneka and for Precision Probiotics. Could you speak to some of these opportunities?
Yeah, sure. Actually, it's interesting because in Latin America, so Latin American market for probiotics, one important aspect to take care of is that is a market that is HCP driven, is healthcare practitioner driven. So the main gatekeeper in the recommendation of a product is not an influencer that you can see in social media, but your medical doctor. And that makes the market be more sophisticated, more complex in terms of the clinical substantiation of the products that we offer into market. And that, in a way, draws a very bold line between products that can be a little bit banal in a way, versus products that are entitled to be recommended by a practitioner. Keeping that in mind, we see that the concerns of the market are quite related to things that are just not limited by the gastrointestinal health. We see that there is more and more awareness in the market on the gut-brain axis. For instance, we see that, for instance, stress or sleep or even mood or anxiety are things that interest the market, and that's quite new as well. But practitioners understand that the product can help into stress, not just mental stress, but also gastrointestinal stress, like IBS. Actually, IBS is an underdiagnosed condition that many people can make a confusion with general stress with gastrointestinal derivatives. So this aspect is important in the market, and we see that the very interesting products are popping up to address these particular conditions. Cholesterol obviously is also a thing of a high interest by the market, because unfortunately Latin America there is a high prevalence of hypercholesterolemia, and next to come will be non-alcoholic fatty liver. That is also a huge issue in developed societies, but also in Latin America. And also, obviously, there is the part of overweight, obesity, due to the fact that there is a change in lifestyle that happened very fast in the past few decades that has a derivative microbiome. Maybe we'll touch base on that. And also, another one that I want to just draw a little bit of an interest is the eye health, because we recently introduced into the market the world's first eye drop with a postbiotic, or using a heat kill probiotic on it, because we believe that despite eye health may seem far away from the gut or microbes can play a role as well on dermal tissues and conjunctivitis dermal tissue, and we managed to develop a better product for dry eye using one of our strains.
Mm-hmm. It's interesting that cancer is at 5% of affected, but everyone's, it's of a high concern within the region. I would have expected to see a higher prevalence of cancer in the region, but in heart disease, because heart disease is positively correlated with obesity, and but heart disease is at between 5 and 10% affected. So it's interesting, the empirical truths about the health condition in the region.
Yeah,
but
sure.
Go ahead. I'm sorry.
No, I was supposed to say that on the right side we have things that are not life-threatening, and when it comes to life-threatening conditions, are fortunately less present or less affected in the population.
Right, and obesity and diabetes has been a topic of research within the recent past. There is a study that was done by the Department of Epidemiology at Albert Einstein on gut microbiome composition of the Hispanic community that migrated from Latin America and the Caribbean to the U.S. And this speaks to the dynamic, Jordi, that you were speaking about in that process of migration. What was manifested or studied was the loss of those microbial old friends, and how that was manifested in the community having health problems that they didn't have previously within their lineage. Fascinating study. The conclusion was, particular aspects of the microbiome may explain unusual epidemiological patterns observed among the Latino community, such as high prevalence of diabetes, obesity, and asthma. And so my question is, what are some of the events within the modernization of society that causes us to lose, these microorganisms that are really important to our survival? I mean, we're trying to survive by becoming more sophisticated, but at the same time, we're hurting ourselves, it seems.
Yeah, sure. Actually, so again, going back to science, in the beginning, it was thought that the lifestyle was the prime affection to understand how individuals may respond into an environmental condition. Then we understood that genetics was playing a role into different aspects. Then we understood that epigenetics was playing also a role into beyond genetics. Epigenetics was playing a role, and no matter if we had big genetic similarities, the difference in epigenetics, that epigenetics is much related also to the origin of the people, and it's an imprinting that can be inherited generation after generation. But epigenetics was a new discovery to understand how different, or in principle similar, individuals may react differently to the same environmental conditionings. Now, few years ago, it was understood that microbiome was also an imprinting that was conditioned the different reaction into the same environment. And actually, microbiome, interestingly, has been pointed out to be partially inherited. We know that, for instance, in research that has been done recently, that mother and children have similarities in microbiome, or relatives living under the same roof in the same house have similarities in their microbiome due to this crosstalk with the environment that conditions the composition and the function of their microbiome. So in this example of this paper, we understand that the gut microbiome of a community that has migrated relatively fast in the context of human history to let's say a lifestyle or an environment that is far away from what they were used to in terms of generational let's say evolution. The differences in the gut microbiome of this population of origin made them react differently than the population living under the same environment. And that has made them be more prone to develop issues like obesity. And obesity is not just related to this lifestyle that we understood in the beginning. Obesity is not just the calorie intake, because for the same calorie intake with different microbiome composition, you will develop an obesity or you will not develop this obesity, because microbiome can condition the energy metabolism, can condition the lipid intake, the absorption of particular nutrients and calories. And that's why yet another prime example that we need to look after the microbiome and take care of the microbiome through the right diet, by the right intake of probiotics, by the right lifestyle intervention, so we can protect ourselves, no matter our origin, from different issues that can be driven from the perspective of microbiome.
We started out by saying Kaneka Probiotics is committed to promoting business development to provide solutions that support healthy and energetic lives. I'd like to add that, you're doing good work to improve the quality of people's lives, which is really important. So congratulations. You guys are doing important work there, and we'll be following you from Panama. Jordi, thank you for your time. It's been enlightening. Your wealth of information, and good luck in the future, and we'll be keeping in touch.
Okay, it's been a pleasure. Thank you for the opportunity and the interest.
All right, take care.
Bye.